Hey, hi there. In today's video, we'll be discussing about a descriptive statistics and how it can be implemented in Python. Okay, so let's first import all the necessary libraries. Pandas as PD, NumPy as NP, right? Seaborn as SNS, and then read a particular data set, which is called as insurance. We'll take an example of a data set, which is insurance. Rather than going to the problem statement, let's just first understand how to calculate these parameters for different attributes or variables present inside my data set. So first, let's read the data set. So once we read the data set, you have these many columns: age, gender, sex, BMI, children, smoker, region, and charges, right? So we have a row level information of different customers. So once we do df.describe, we know that we get the statistical parameters of the continuous distribution only, right? So the number of the count, the mean, standard deviation, minimum value, maximum value, the quantiles, right? 25 percentile, 50 percentile, 75 percentile, and maximum value. And you get all these values with of course, for numerical variables. Now, if I want to extract the statistical parameters of object columns which are categorical and have string characters, right? So they'll be those columns are sex, smoker, and region, right? Because there is strings inside these columns, and that is how we get the count, the unique values. What are unique values of sex, male and female, smoker, yes and no, region, probably there are 4 regions. Top means that the mode. Top means the mode, right? The mode of these columns. And frequency is the frequency with respect to the mode. How many males are present? How many no's are there? How many southeast values are there? That is what it basically means. Count means the entire count of the observations, right? So df.shape will give you the count 1338, right? Clear? Okay, so now let's first look at the measures of central tendency. Now, if I want to look at the measures of central tendency, triple M, right? How will it work? So let's first try to extract the numerical values, right? Because mean, median, mode, especially mean, median cannot exist for string columns, right? Okay, so we need the numerical columns. Actually, mean, median, when I say mean and median, they typically tend to exist for continuous values, guys. Please understand this, right? Although we did calculate the mean and median for discrete values as well in the PPT because we had to do it. But when it comes to exploring data in the real world, right? Typically, we consider the continuous variables for calculation of these parameters. So out of these, age, BMI, and charges is what it tends to be continuous, because children, if you go to the children column here, this clearly seems to be discrete, right? This clearly seems to be discrete. In fact, you can check it like this as df of children dot value underscore counts. If you do that, see, a family can only have up to 5 children max, right? So these are discrete values. So I'm not considering that in my continuous columns. So these are actually my continuous columns. No problem. Okay, so once we do that, right, once we get all these continuous columns, right, so now once we have these continuous columns, let's try to calculate the mean, median, mode. Now in order to calculate the mean, median, mode, we do have functions in Python directly, right? Suppose if I do df of c1 means age. Okay, so it's like saying df of age, right, dot mean. If I do, I'll get 39.2. Okay. To calculate the mean, I can use NumPy module also. np.mean also I can use. And I can simply do df of np.mean of df of c1. It will give me the same exact value. Same goes for median as well. Okay. Same goes for median. Clear? Okay. So whichever you use, not a problem. But when it comes to mode, now for mode, you get a series. You do not get the direct value. You'll get a series. So please be very careful, guys. Okay, you always get the series, because there can be more than 2 values which have the same highest frequency. So if you want to get the value ultimately, then we have to use slice of 0. You'll get the values, right? Okay. However, we did not have something which is called as np.mode. It does not work. Okay, so be very careful. So mean, median can be calculated both from NumPy and without NumPy, but mode typically cannot be used, cannot be calculated using NumPy. And mode gives you a series. Okay, mode gives a series. So use slicing information to get the value. Okay. Okay. So once you run this, you can see you get all the values directly. Okay. Now here, if you notice, the mode is actually less than the median, which is again, in fact, less than the mean, right? So typically, when does it happen? Remember the statistics theoretical lectures which you had attended in my videos. Mode is less. So mode is typically this, the highest peak, then median, then mean. This will typically happen when you have outliers on the right hand side, higher values on the right hand side, right? Just slightly, skewed towards the right, right? So if I do this plot, just to check, if I do sns.displot of df of c1, I get this distribution. So you can see here, maybe there are some values which are on the higher side. But again, this distribution typically does not seem like a bell curve, right? It does not seem like a bell curve, to be very frank. But it's okay. We'll deal with in EDA, in exploratory data analysis, we'll see how to deal with these columns. Okay, which do not behave like a bell curve. It almost is like a uniform distribution, but just that one particular interval is very high. Right? So maybe it doesn't have as much as unique values as we're supposed to. Maybe age is discrete. We do not know. Right. So we'll talk about this in detail in exploratory data analysis. Right. But for now, let's keep it like that. Okay. The purpose of the exercise is to find out how do we calculate mean, median, mode, and other statistical parameters, which comes under descriptive statistics, right, from the given attributes or given variables. Now, second column, what was the second column? Second column was BMI, right? So let us calculate the same thing, mean, median, mode for BMI. Okay, so mode gives you a series. So again, I'm using a slice of 0. And when you put comma like this, it will automatically give you a tuple. Okay, so whenever you write something like 2,3, it will automatically give you a tuple. These things we have, I think we have already covered. Right? See, you can see 30.6 is 13.4, 30.33. Now, here, if you look at it, mode is greater than mean, not by much, 2 points, whereas mean and median are almost very same, almost similar. So this may not be that much of right skewed or left skewed, right? Let's try to have a look at the distribution. So to view the distribution, what I'll do, sns.displot. So that is why, guys, I have arranged the course in such manner, because you already know what displot does now, because you have already gone to the visualization module, right? So the main, purpose behind me building this course, giving my entire experience, is to make it easy for you to learn. Right? There'll be hundreds of other courses out there. I'm not going to talk about those, but it should be easy for anyone from any background to pick up these things, because these are not rocket science. This is something which you should know, because ultimately, whether in whichever domain you are, you will be handling with digital data. And these things are very, very important for you to analyze data. So the third column now, so you can see that before you go to the third column, you can see the BMI is in fact, indeed, not much skewed, right? It's almost like a normal distribution, right? Almost like a perfect bell curve, which is pretty good for us. No problem. We can find out the mean, median, mode directly from that. So in the theory part, we had covered the descriptive statistics part 1, which covers the frequency, measures of frequency, and measures of central tendency. In the next video, we'll be covering measures of variation and location as well. Okay. So now the third column is charges, okay, which we saw. And if I want to find out the mean, median, mode, we can directly do it like this. Again, to repeat, NumPy doesn't have the mode attribute, so you have to directly use the mode function. The rest for the rest, you can use the mean, median function, no problem. I'm using NumPy, easier to use. Okay. So here mode is significantly less than the median, and it is significantly less than the mean. You can see there's a huge difference, 13,000, 9,000, so 4,000 difference. Mode is 1,600, 8,000 points ka difference, which means that it's highly right skewed. It'll be very, I suspect that it'll be very, very right skewed like this, because these values are influencing the mean and is pulling it up, right? So let's try to see the distribution plot. So you can see here, guys. See, huge. Okay, now you cannot call these as outliers. Huh? You have to be very careful. Yes, there are some high value which has very low probability, but again, we'll talk about that again in EDA, expert data analysis, after we finish the statistics part. Okay, so once we have this, right, so we understand that it's a right skewed distribution, it's heavily right skewed, where the mean is higher than the median, which in turn is higher than the mode. So mode lies somewhere here, 1600, mean is some 13,000, and then median is again 9,000, right? Okay. In the next video, I'll also show you how to, in this scatter plot, in this distribution plot, can we point out the mean median as well? Okay. So suppose I want to plot the mean median of C3 and also the mode. How will I do it? PLT dot scatter, or I can simply do SNS dot scatter plot. Median and mean. All of them. Let's do all of them. No problem. Okay. This is the x-axis. Scatter plot requires what? X comma y. So y I'll put as 0. Why? Because I want to plot it on the x-axis. Okay. I want to plot these data points, which is mean, median, mode, somewhere in the x-axis. Okay. Let's see if I can do it. And let's say color is equal to, say, red. Will this work? So you can see here, you see these red data points, and also you can mark it as this basically represents the size of these circles. By default, the marker is circle, right? Okay. See? Pretty clear, isn't it? Right. So this is where the mean, median, mode lies. Okay, right? You can reduce this also, no problem. So this is probably your mode was least, right? This is the mode. This is the median. This is the mode, and this is the mean. Mode, median, and mean. Right. Okay. So there's a significant difference between mode and the mean and median. This difference is also not that small, just 4,000 difference, right? Because mean was 13,000 and median was 9,000. Okay, great. You can, always use this to plot and check. One more thing, guys, I wanted to show you is that in this scenario, we were trying to calculate the mean, median, mode and plot the distribution plot one at a time, right? We were doing it, for every column separately. But in upcoming, further down the road, we will be using a loop to basically do it for us. Otherwise, it will take a lot of time, right? Now, if you want to see the histogram, if I told you, right, measures of frequency, how do we calculate frequency for continuous data? For discrete data, it's very simple, right? We simply find out the count of the individual different categories. But for continuous columns, we have to create the bins, the intervals, which I showed in the PPT, right? And then we calculate the frequency of those bins, right? Correct? We count how many data points are there which lies in that particular interval. So, but we don't need to do that because we already have a function called this plot, which does it for us. And typically in this plot, we do this, okay, to get the curve. But if I want to want to get the histogram instead of the curve, I do KD is equal to false. Okay. If I do KD is equal to false, what do I get? I'll get a histogram. Very simple. KD is nothing but kernel density estimator. It's the estimator which draws the curve, the probability distribution curve. Now, if you can see here, once I made it KD, the y-axis change. Just check again. This is probability. But as soon as I make it KD is equal to false, it gives me a histogram. A histogram represents frequencies, not probabilities on the y-axis. Right? So these are the bins, 15 to probably something, 20, 22, 22 to 24, something like that, right? And I can also specify how many bins I want. If I want to make 50 bins, I want 50 such, bins, or I want 100 bins. We can keep on, specifying those as well. Okay, right? So this is what the histogram looks like. So now for discrete data, for discrete data, it is very simple. How do we calculate the frequency? Let's see. First, let us extract those columns which are discrete. So by nature, string columns or object columns will always be discrete or categorical, right? So I've selected the object columns. I'm not going to repeat these codes again and again because I've done this multiple number of times in the previous video, guys. Please check in Pandas video. You can get into it. Pandas. Okay, so sex, smoker, and religion. So sex, smoker, and religion are, of course, categorical variables, object columns. However, there is one more column in the numerical data set or numerical columns, which was discrete, and it was children. Remember, when you go up, I did children.wellness count. See, this was also discrete, right? So Python is not going to understand. So Python will not be able to make out whether children is discrete or not, because by nature, you have only two options: object and float and integer, right? Okay. Not all integers will be discrete. Not all integers will be continuous. Right? It's for you as a data scientist to figure that out. It will be that you can do by first visualizing the distribution plot, or getting to the unique values. How many unique values does this particular column have, and etc. Right. So here I have to manually put it down because children is actually a discrete column as well. Okay. Right. So you can call this categorical or discrete. Typically, if you go back to our 101 data types of data in the first video, right? What did we have? We had numerical columns. In numerical, we have continuous and discrete. We had numerical columns and non-numerical columns, or what we call as qualitative, quantitative and qualitative. In qualitative, we had ordinal and nominal, right? So all these three are actually categorical columns, and this was continuous columns. So let's just call it as categorical columns or discrete columns. Discrete is the children, right? Children is discrete. So once I have all the categorical columns, I will now loop over these categorical columns. Sorry, this should be categorical. Okay, I loop over it for I in categorical columns. Now I'll first find out the I'm basically trying to show the frequency of the mode, right? Frequency of the mode value, right? Because dot value underscore counts will always give me a series of the different labels associated along with its corresponding frequency, arranged in terms of descending order of magnitude. So if I do df of let's say region dot value underscore counts, you can see here southeast is the mode. This is 364, and that's why it's occurring at the top. So if I do values of 0, I'll get the frequency of the mode. Okay, and if I dot index of 0 will give me the modal value, or I can simply do df region dot mode also to calculate the modal value, which is southeast. Okay. All right. Okay. So this is what I have done. Next, what I have done here, let me again explain it to you. I have also found out the proportion. Okay. So if I want to find the proportion of this, how do I do? df of shape of 0 divided by each of these values divided by the total number of observations. So this is my proportion. Clear? Okay. So that's exactly what I've done here. Frequency, find out here, fill proportion. Proportion nothing but the frequency divided by number of observations. Rounding off to 2 decimal places. So once I have it, I'm printing out the column name, colon, the mode of that particular column, its corresponding frequency, and its corresponding proportion. Very simple. Right? And if I want to find out now if I want to express this in the form of a figure, what will you do? Just like for continuous columns, we have distribution plot, frequency histogram. For categorical or discrete columns, what we have something which is called as the count plot, right? So for I in cat calls, sns.countplot of df of I, plt.show. Now I'm not using subplot here to create a beautiful grid and show it to you. I'll show it to you in the next video. Okay, not now. Let's just plot it and try to check what we get. And I'm setting a figure size for each of these plots. See here, female, male. Now if you see female, male, 676 was male. So of course, if out of 1300, 676 is male, then female is slightly less than that. So almost 50%, 40% ratio. See, 51%. 51% is male, 49% will be female, right? Then you have smoker, yes and no, right? Okay, 80% is actually smoker, which is non-smoker, which is no. See, no's probability is okay, and that is 1064. Very nice, isn't it? Next, we have region Southeast 364 accounts for 27%. Southeast 364, slightly matching with this, definitely matching. And the rest everything. This accounts for 27, rest is 24, 24, I believe. Next, let's see. Next is children. Children, 0 children, it has the maximum count, which is 574, and accounts for 43% of the entire data set. So 43% of these people do not have children. And that 43% accounts for 570 something, which is this. And this is 43% of the entire data set. If we add all of them, rest of them, it will account to 57. Right? Correct? So these are my modes. The highest bar will represent the mode. Here, very simple. Please go through these exercises again, IPNV files again, and try to connect with what you have learned in the presentation or the theoretical class, theoretical videos, right? If you're able to connect, then that is how you should build your concepts. In the next second video, will be dwelling into the measures of variation and measures of location as well. Plus, I'll be showing you how to plot all these diagrams in one particular loop, right? And we'll try to extract all the parameters from each of these columns and display it along with the figure of distribution or count plot or whatever it is. Okay. So stay tuned, guys. See you in the next video. Thank you.